So in our project, what we did originally with the implementation is that we basically say create a new user, and we took that clear text password and we stored it straight in the database. We said let's just store it, no big deal. And for our environment, it wasn't a big deal. It didn't matter because we were just trying to get the app up and running. And we were doing clear text password checks, and we were just comparing strings and making sure everything worked. Well, as great as that is and as easy as that is, it's not very secure. Someone gains access to your database, someone hacks you and steals your database, someone, I don't know what. They end up gaining access to all of your passwords because they're just stored in a field. So typically what happens is you have different gates of security, I think is the term they use. So your first gate or secure measure that you put in place is you establish an encrypted connection between your browser and the server. So anything that's typed into that form that's shipped across the wire is encrypted and shipped to the server is in an encrypted format. So that data then is secure from your computer to the server. In theory, no one can read it, no one can access it. Once it gets to the server goes through, and the first step it does is decrypt it, because it doesn't understand your code is not written to deal with encrypted data. So when you actually get that password and that username, it gets sent to you in plain text. It's then your job to actually encrypt it. Now, there's two different forms of encryption. And actually, there's only one form of encryption, and the other one's hashing. So you have encryption, which is two-way, which means I take a value and I encrypt it, and then I have a special approach to decrypt it. And encryption and decryption, being able to do that two-way process, is a fairly sophisticated, even in code, step to take, because it has to do with you have to establish what are called vectors and encryption points. And basically, you're establishing parameters for encryption. And those can be done statically or they can be done dynamically. Statically is you pick a series of numbers out of the air, you hard code them into your application, and then any encryption that happens utilizes those values and you encrypt it, and then when you need to decrypt it, you use those same values to decrypt it, kind of like the public-private key thing. And for small-scale apps that need minimal security, that's fine. Most common scenario when you'll see an encryption-decryption situation is whenever you give some website your credit card number. So every time you make a purchase, they can't ship the encrypted value to the bank. They have to ship the decrypted original credit card number and validation code and expiration date to the credit card company for processing. So that's two-way encryption. They take your credit card number, they encrypt it, store it in a database somewhere, and then they turn around and then decrypt it when you make the purchase. So Amazon has an encrypted copy of your credit card number. eBay or PayPal, they have that as well. Any website that you probably buy something from and you check that box for them to remember who you are or remember your credit card, somebody somewhere has the keys to get your credit card. Okay? So that's two-way encryption, and it's only needed in isolated situations. Actually, I shouldn't say isolated. It's actually needed in most common situations if you want to be able to decrypt your data. Passwords are one of the few things that you do not need to be able to decrypt. Does that make sense? All right, I have two people shaking their head yes. Why?
Store the hash, compare the hash, and
Yes. So, if I hash the password, a hash is a one-way encryption. Basically, I take that clear text, I perform a hash algorithm on it, it generates garble like we saw in the certificate request. I store the garble. Then the next time you log in, I get an arbitrary string as your password, whatever that string is. Whatever you typed in, I get it. I then perform the same hash, and then I compare the hashes. Now, the higher level of encryption you use and the better encryption hash algorithm you use, the more unique those hashes will be. Now, I say the more unique because there is the potential that you could have two different strings, clear text values, that can generate the exact same hash result. Typically when that happens, then people come out and start complaining that that encryption mechanism or that hash routine is no longer valid. But it's a real thing. And it happens, but the more it happens, then it becomes less authentic. So to combat that, there's a third process that you can utilize, which is called salting. And salting says, I'm going to take a password, I'm going to hash it, and I'm going to take that hash and I'm going to utilize some other value, either an arbitrary number or a binary interpretation of something else. I've seen people talk about using things like they'll take the state code and they'll convert it into a binary, and they'll take that numeric representation and they'll treat it as a salt value. So you take the hash, you append the salt, and then you rehash. And that hash is what you store. Because the salt and the hash, they have a relationship. Sometimes they're unique within a system, sometimes they're unique within a record. So if somebody changes their state, you actually have to go through and rehash stuff. You actually have to go through and do that revalidation. So it all depends. Depends on who you are and how you're handling things. So that's quite often when you see sites go, hey, you decided to change some validating piece of information like your state. We need you to log in again to verify you are who you are. Well, they're doing that for two reasons. One is they want to validate who you are, doing the current hash implementation with the salt, and then once they store the new state, they want to actually be able to rehash and resalt your value, keeping the state and the hash in sync. Because if you update your state and you don't update your hash, then technically your password's no longer valid. Because your salt value changes. So there's a lot of routines and there's a lot of differing hash salt approaches. So I'll kind of leave that up to you, because none of them, there are good ones and there are bad ones. And that's kind of just a social decision for the most part. The way that you go about doing it is kind of your decision. There's lots of ways to do it. What I just explained to you is one way. I'm not saying it's the right way. I'm not saying it's the best way. But that's the fundamental idea. All right. So I'm going to walk you through a hash and how you hash something within .NET. So what I'm in right now is I'm in my create user account. I'm in the postback method of creating an account. It's where I go and I take my user data, stick it in a DTO, and then save it to the database. Well, before I put it into the DTO, I need to generate a password hash. So here I'm doing some validation, making sure that the password confirm and the password match. I then need to add here hash password. So I'm going to create a string, which is my password hash. And I'm going to create a byte array, which is going to be the pass hash buffer. And the hashing algorithms generate binary arrays or byte arrays. They don't generate strings. You have to then take the strings and convert them into bytes. Actually, the hash algorithms deal with just bytes, so you have to go two ways. All right, so we're going to start out with, we have the create view model .password. So that's the clear text password. And I'll store it in a string called clear text. And then the hash password buffer is the middleman. So there's system.security.cryptography. And then you have a whole bunch of stuff in here. A whole bunch of different cryptography options. Yes, I can. No, I can't. Yes, I can. So some of these should look at least mildly familiar to you. Hopefully you have things like AES.
What's the line above that?
Above AES, there is nothing above AES.
So above system.security.
Oh, the line? She told me to scroll to the top. Is that a compromise? So we have AES, crypto service providers. Actually, let me just do provider. So there's all the different providers. AES, CNG, DSEC, DSAC, MD5, RC2, RNG, RSA, There's probably a T triple stack, HSA. So you got all kinds of options. Now, depending on, again, security profiles and preferences, there's different routines. Some of these are two-way, some of these are one-way. So depending on what your needs are, depending on which provider or algorithm you use. The AES and the triple desk are two-way. The SHAs and the MD5 are one-way. Those are hash generating algorithms. I don't remember what the R ones are. Anybody remember? Or no? I feel like the RSA one is two-way, the RNG is one-way, but I'm sure there's the Wikipedia article that will tell you those. So, and there's new ones being invented, so they are what they are. Yeah. So we can go with really any of them. I'll just do MD5, which some don't recommend, but again, it's up to your level of security. So we'll go ahead, and this is a static, or I should say static, it's a utility class, so you have to call a .create to create an instance of this. So I'll just do var crypto provider. And then we're going to call compute hash. So you'll notice here that it takes in a buffer and it returns a buffer of bytes. So before we can call compute hash, we first have to get a buffer of bytes. And to do that, there's system.text.ASCII encoding.get. Nope. ASCII, hate this, .get bytes. You pass in a char or a string, and it will give you back an array of bytes. So you give it clear text, it'll generate the bytes. So we're going to pass in the clear text pass, and this will be a byte array of clear text buffer. So that's creating a buffer, a byte array, typically called a buffer, of your clear text. So the bytes that are in there will be the ASCII representations of each one of your characters in your password. So then we'll say compute the hash on the clear text buffer. And we're going to capture that in the password hash buffer. And then the last step is we're going to do that same ASCII step but backwards. So then we'll have the password hash equals system.text.ASCII encoding ASCII get bytes password hash buffer. Alright, so now through those steps, we've taken the clear text, converted it to bytes, taken those bytes, computed a hash, taken the new hash value, which is just an array of bytes, and converted it back to ASCII. And now we have essentially a garbled string that is that hash. We then take that string and we store it in the password field. So instead of storing this down here on our DTO, we store password hash. All right? All right. So now when we create an account, the passwords get hashed. Now, in order for us to do this again and do it successfully, we have to then copy the encryption routine and move it into our login. So the first thing I want to do is I want to grab all this. I'm going to instead create one routine called hash password. Hash. Okay? So that's a stub. I can use the refactoring to generate a method that matches the signature of this little stub. So I hit that button, and it'll create this private method for me right here, which I can paste my code into. So P is my clear text password now, so I can get rid of that. And then the last step is for me to return the password hash, not the buffer. Deal with those in a second. So this basically becomes a function. So whether I'm creating an account or logging someone in, I don't have to worry about am I using the same encryption routine, am I doing the same steps. I just call one method. If I need to change my encryption from MD5 to SHA-256, there's obviously more work involved than just doing that, but I make one change here to get myself up to whatever spec I want to get myself up to. And then it's done. I don't have to worry about where else did I make that encryption call. I have one function that I use everywhere in this controller, and that's what does the encryption. Typically, I like to put private methods at the bottom. Just keep the public at the top, private at the bottom. So we'll do the same thing now for my login. So this is my HTTP post. Let's see here, cookie. All right. So this line here checks for user with user and password. So the step before this, actually we can do it all the way up here, is generate password hash. So string pass hash equals hash password using the login view model password. So down here on lines 52 and 53, we're actually passing in the login view model p word. Instead of passing that in, we'll now pass in the password hash. All right. So that is the same encryption steps. So we take the clear text that comes from the form, we hash it, and then we validate that against the database. So that ensures that we're only storing password hashes in our database. Is anybody going to ask now the next obvious question? What happens with all the user accounts that we have in the database right now? They'd be broken. Because now when we log in, that password will be hashed, and it will not match what's in the database. So as part of the deployment, if we were putting this into production, part of the deployment process would be, we're going to take the site down for a period of time, and then we're going to run a routine one time that goes through and hashes every password that's in there using the same hash algorithm. We hash those passwords, update them in the database, and now we have hash passwords in the database, so then when we deploy this, that deployment is running with new hashed passwords. So that part, it's not so much about the code, it's not so much about the database, it's about thinking through the process of how do I roll out this update that I've now added a layer of security. Okay? And in some cases, I've seen dynamic rollouts where the app will still maintain the old functionality. So let's say you go and you log in, type in your password, clear text in the database. The app goes, yep, that was a good password. I'm now going to take your password and I'm going to encrypt it. And write the encrypted hash into the database, and then we'll add a field into that table that says whether or not that password has been re-encrypted or not. Because once it's been re-encrypted, then we no longer want to check against clear text. You basically kind of do a little bit of a two-step inside the database. Is it encrypted? Yes. Okay. Hash it and then validate. Is it not? And that's where you run into cases where you ever had, have you ever dealt with a website that said, hey, we've had a security breach and we need you to reset your password? All right. So usually if you come and you log in for the first time, you log in and the first thing they say to you is, all right, stop, change your password. It's because they probably implemented something different in their algorithm and they want you to change your password to change it. And they want to re-encrypt that password into something that's valid because they've changed their routine on the back. All right, so let's go ahead and run this. Oh yeah, we have build errors. convert bytes to chars. Oh, because this is not get bytes, this is get string. Sure. String to stream. Line 200. Compute. Oh, because this is supposed to be not clear text pass, but clear text buffer. That's 6. All right. So I was not passing the buffer in here before, so that was why I was getting the compiler error. All right. So if we run. All right, so then if we go to sign in, create a new account. I hit create. I now logged in. That it be broken at the top, that was me messing around with something, but it wasn't really broken. So if I jump into my database, table, user, and I show table data, there's my encrypted password. Say that again? I wasn't going to, but if you want, I can do it.
I was just wondering, is it required for us?
No. Well, if you implement it the first time around, you don't have to worry about encrypting. So your project is still hasn't been delivered, right? So you can go through and implement the encryption now and not have to worry about encrypting both passwords. Any other questions?